So let us look at this interesting Olympiad style equation. So we have solved 9 raised to the power n minus 4 raised to the power n is equal to 65. So let us first of all write what we have. We have 9 raised to the power n, and we can now raise this to power 1 minus 4 raised to the power n, and we can raise that to power 1 because raising a number to power 1 does not change the value. So that's equal to 65. So remember, we can write 1 as a fraction. If you have 1, you can write that as 2 over 2. And 2 over 2 can be seen as a product of numbers, that is half and 2. So it means therefore that we can rewrite these powers in this form without actually having to change the values. So we're going to have 9 raised to the power n raised to the power half times 2 minus 4 raised to the power n raised to the power half times 2 is equal to 65. So we can now apply the third rule of indices, which says that if you have a number a and it is raised to the power n and it is also raised to the power m, that is the same as a raised to the power n m. So let us apply that in our equation so that we can take the half into the bracket using this rule so that we have 9 raised to the power n over 2, and we leave the 2 outside. Then we do the same for the second part, that is n over 2 all raised to the power 2, and that's equal to 65. So now we can let the terms inside the bracket be other numbers. Like we can say let 9 raised to the power n over 2 be x, and the second one, that is 4 raised to the power n over 2 be y. So if we write the equation will be x squared minus y squared is equal to 65. So remember, according to the quadratic identities, if you have a difference of squares, that is a squared minus b squared, that is the same as having a plus b times a minus b. So it means our equation can be written as x plus y times x minus y is equal to 65. And remember, we can also rewrite 65 as a product of two numbers. So we can say this x plus y times x minus y is equal to 13 times 5. So you just want to have similar things on either side of the equation. So we have this product equal to that product. So it means we can equate corresponding terms in that product. So you can say the first entry, that is x plus y, is equal to the first entry on the right hand side, so that we have x plus y being equal to 13, and we call that equation 1. And we can also compare the second portions. The second term in the left hand side is equal to the second term in the right hand side, so that we have x minus y is equal to 5, and we call that equation 2. So now we can solve for x and y using any of the methods. So from equation 1, if you were to use substitution, we would say that x is equal to 13 minus y. So we can substitute these in the second equation so that we have 13 minus y is equal to 5. And if you collect like terms, you're going to see that minus 2y is equal to 5 minus 13, which is just minus 8. We divide both sides by a negative 2, we have that y is equal to 4. And if y is equal to 4, we can get the value of x. Remember, x is 13 minus y, and y is 4. So it means x is 13 minus 4, which is 9. So we have the two values, x is 9 and y is 4. So remember what you said about x. You said that we are letting 9 raised to the power n over 2 be equal to x. And you have found the value of x to be 9. So it means you have this equation 9 raised to power n over 2 is equal to 9. Remember, we can write 9 as raised to power 1. And you can see that the bases are the same, 9 and 9, so it means the powers are also the same. So it means n over 2 is 1. If you cross multiply, you're going to find that n is equal to 2. So it means the value of n is 2. Even if we did that with the value of y, remember we said 4 raised to power n over 2 is equal to y, and y according to our solution is 4. So it means we have 4 raised to power n over 2 being equal to 4. And we can write 4 to a power 1, meaning n over 2 is still 1. And if we cross multiply, you're going to find that n is equal to 2. So we can check if that value is correct. Remember, we had 9 raised to power n. So n is 2, so that is 9 raised to power 2 minus 4 raised to power n, that is 4 raised to power 2. And let's see if we are getting 65. So 9 raised to power 2 is 81 minus 4 raised to power 2 is 16. Let us see if that is 65. So 81 minus 16 is 65. And we have 65 on either side, meaning that our solution is actually correct, that n is 2.